that comes as a necessity is sensors. As Sir said, yes, cloud plays a very important role, but even without going to the cloud, you could have everything on the same manufacturing complex through a local network. Then cloud is secondary. But the primary thing that you need to make the operations smart is sensors. But sensors is just the starting point. Sensors by themselves can't do much, right? And that's where IoT plays a very important role. IIoT is just a term coined to emphasize some kind of sensors which are complicated, right, and have more capabilities, and which you won't find in use in the domestic space. Okay, so surveillance cameras and thermostats, or humidity measurement, these kind of things are all there in domestic setup, like we saw in that one slide where I showed you the kind of IoT sensors for so many different equipment in your home, right? Industry is far more than that, and more important is it has to handle measurements of complex changes. Imagine measuring the ratio of two components going into a reactor, right? And then measuring, or if you have to automatically use a sensor to measure the quality of the post reaction stream of gas or liquid or whatever, those are quite complicated tasks. To measure even simple thing like what Mr. Gunti mentioned, in condition monitoring, you need to measure the vibration, you may need to measure the temperature. In the industrial setup, it's not as easy as it is as home, because in home the environment is much cleaner, safer, and accessible. In the industry, yes, when operations are down, everything is accessible. It's still not easy. There is a lot of mess around so many different equipment. Okay, and then positioning of the sensor and getting it wired and all those things are far more difficult. So that is one big difference in smart manufacturing. So as I said, we will just try to understand, and all of this put together, actually is what is covered under robotics, right? So robotics, you will be using robots in smart manufacturing, and then you will be also doing robotic process automation, and that is primarily to remotely or automatically control machines, right, through artificial intelligence and machine language. And he did mention one word, digital twin. I don't know how many of you actually understood. Can anyone tell me, did you understand anything by the term digital twin? I think not, right? Because this is something which you have probably not even heard of or even seen. But that's one of the big areas that's growing very fast today, and you'll soon understand why it is like that. There is also one more term called lights out manufacturing. Again, has anybody heard this phrase, lights out manufacturing? Okay, so lights out manufacturing is also a new approach, which is like taking smart manufacturing one more level higher. Essentially what it means is there is nobody inside the manufacturing uh, facility at all. Everything is from remote. That's like you can switch off all the lights in that place and it will still continue to manufacture. How amazing that would be. But that is almost, we are almost there, and that's also one area which we are working. uh, I think he mentioned the term prescriptive maintenance. Do you recall anything about this word? I think I'm sure you all know predictive maintenance, right? Have you heard of this term called prescriptive maintenance? Okay, fine. So I take it that, and that is the reason I am continuing into smart manufacturing. I want to add these things to your knowledge of smart manufacturing, because these are the upcoming or emerging changes that you will see in the field of smart manufacturing. Of course, as a country in India, the extent to which smart manufacturing has been implemented is, I would say, in the nascent stage, but not so nascent. Maybe I have another session on robotics and RPA, so we'll see some more details there. But just I'll just give two clues. It's like uh, Hyundai has 580 robots in their Sri Perumbudur plant near Chennai. This one produces one car every 30 seconds. Now, just try to imagine, how do you manufacture one car every 30 seconds? And one of the key features there is the use of automation and robots. Okay. uh, you will be surprised to know, and even I was surprised to know, that Maruti Suzuki has 5,000 plus robots on their assembly lines. I think it might be a consolidated figure for all of their manufacturing facilities, or it could be at one of their biggest facilities in Manesar. Okay, whatever it is, the point is, this is started, it is already there, but not in such a big way as what we'll be seeing in this video, which is to do with the company called Nissan, uh, with the help of a robotics company called Fanuc. And this is happening in Japan. It is almost on the verge of completion now. Okay, so let me just fill you in with some small points here. That is, why do we call industry 4.0? I think at least you should know that, as even as management students, when you have learned about industry 4, you should know why it is industry 4. So it's just to, we are only kind of tracing the evolution of the manufacturing process, and starting with mechanization and getting a steam engine. That was the start of industrial operations and some kind of manufacturing. Okay, the weaving loom, and the steam engine, and that itself necessitated mechanization. And then you move to mass production. So actually the assembly line came in industry 2.0. In industry 1.0, yes, we understood how to make certain kind of machinery and the tools that were required for that, and that helps us to create machines like the weaving loom and maybe other devices. Actually, it's the steam engine that has led to the railways. But mass production, especially, it started with cars. So that came in industry 2.0, where you have an assembly line and it is continuously operating. There is a specific task laid out for each person along that assembly line, and it just keeps on, it's like there is value addition happening as the assembly line moves forward. Okay, industry 3 got a lot of help with the introduction of computers, with the developments in electronics, and with the development in automation. And we have come a far uh, ahead, even by industry 3.0. It's only when internet became robust, when data communication channels became robust, and they were able to handle higher capacities of data flow, right? And we got sensors. When I was working in the industry, and Murthy sir also has worked, he knows, we didn't have the kind of sensors that we have today. Most of it was manual. So if I wanted to monitor the condition of a pump or a motor, I will call in the vibration monitoring team. They will come with their instruments, and they will connect their sensors, which were all kind of manual. So you have to actually connect those sensors. They'll connect it for 1 or 2 hours, and there was a device which would record the readings, and then they go back to their office, take out that, it's like an ECG. Actually, it's just like an ECG of a patient. So they get this printed, I mean, graphical report, and from there they will study the variations and the patterns, all of which can be actually done by artificial intelligence quite fast and quite accurately. Okay, the accuracy is directly related to the volume of historical data that you have. Now this is where it started changing. So when you have people coming and doing vibration monitoring physically, you only get data for a period of 2 hours in the whole day, and this happens only when, as and when, some problems are kind of visible. Visible means my technician, he will take a screwdriver and just put one, the handle on his ear and the tip on the pump, and he could tell me, sir, there is some problem. I think you need to call the vibration monitoring team. That's the way we used to work. So you can imagine that. And so you have data in bits of 2 hours, and maybe spread, at the most it might be once in the week, once we have identified a problem machinery. But it was not like every minute of the day. Okay, That is where the big changes come. So smart manufacturing is now able to do many things because high volume of data is available. For that, it has to be first captured, then it has to be stored, then you need to analyze it, and that is the backbone of smart manufacturing, or rather that is one of the critical components of smart manufacturing, besides the sensors itself, besides the networking technology that is behind, besides the cloud which has allows you to handle data warehouses or data lakes. I think in his presentation he had on one of the slides something called data lakes. You actually end up creating data lakes for almost every critical machine inside the manufacturing unit. And when you have that volume of data, there is no way you can analyze it manually. That is where artificial intelligence, to build artificial intelligence into the machine, you need machine language. Okay, so that is how all of these things are connected. So you have IoT, you have cloud, you have networking, you have data management, data analysis, prediction. Okay, so this is where we are today. All of these capabilities are now there, so you call it cyber physical systems. First, everything was, the important part was the machine on the shop floor. Okay, and the people on the shop floor. You could, I would still say that people are number one, but they are there both ways. Even today people are there, it's just that they are doing a different kind of job. Okay, so industry 4.0 is now we call cyber physical system, because the role that a machine is playing in manufacturing, equally important role is played by cyber or information technologies around that machine, as well as for the entire manufacturing unit. And that is industry 4.0. Okay, let me go to the next slide, and this is just a definition of smart manufacturing as given by National Institute of Standards and Technology, which defines it as a fully integrated collaborative, right? Because now you have data exchange between machines also. Okay, because of the connectivity. So it is a collaborative manufacturing system that responds in real time. That's another critical issue. Now things happen in real time. Okay, to meet changing demands and conditions in the factory, in the supply network, and in customer needs. So actually it is meeting changing demands in three areas. What are the conditions in the factory? Say for example, in a chemical manufacturing company, there is it needs a lot of cooling. So for that you need cooling water. Cooling water comes from the municipal corporation or the nearest lake or river that is there. That, if you will see, many of the companies, they are all located, especially those which use a lot of water, whether it's textiles, whether it is chemicals, they need a lot of water for cooling, and therefore they are quite often located very close to sources of water. In cities like Mumbai, there's no river from where you can draw the water, and the other part is you normally don't use seawater because it's highly corrosive. Okay, only BRC uses seawater, but they have their equipment is also titanium based, so they are that doesn't get affected much by the corrosive conditions. Though give everything being equal, seawater is very bad compared to sweet water. Okay, so you'll find this is the reason why factories used to be close to large bodies of water, and in cities like Mumbai, nothing, you are dependent on the municipal corporation. So when water supply goes down, the 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 first indication will be that, okay, the incoming water has reduced, right? That is sensed by the cooling tower, and the cooling tower starts sending messages to different to the supervisory group, in the control room, but it automatically also starts reducing the load on all the different machinery or equipment related to cooling water. But when cooling water is less, actually your production is going to be less. So it, and now it will do it in a logical way, sequentially, without making a mistake. The a large number of problems that used to happen is when something like this used to happen before the factory was smart, people have to run around. So I remember going and watching inside the cooling tower. Okay, how many steps water is there? So we had steps to go into the bottom of the cooling tower, and the water used to be in collected at the base of the cooling tower. If you have seen any pictures of cooling tower, what you see on top are large funnels where the fans are running. They cool the water that is falling from top to bottom in the bottom it is again pumped back to the top. So there are steps to go because that is required for maintenance, right? So we used to actually go and watch that. Now those things are not required. Then I have to report back to the control room, and then the control room operators will manually start taking necessary action. Obviously, when manual intervention is there, there is a lot of scope for error, especially in terms of timeliness. If you are late by 20 minutes also, you could end up in severe problems. Now that is just to give you a scenario of where smart manufacturing is giving a high impact. Nobody has to do anything. Mostly it is this control room where the supervisors are watching. Alarms will already start blinking and some sounds will also start going out, to alert them that that is a problem. Be alert. And then you have to, sometimes you don't have to take any steps, but you have to see that the expected steps are occurring or not. This is all that comes in real time to meet changing demands, conditions in the factory, in the supply network, and in customer needs. So sometimes it is just that a customer has suddenly placed a large order and he has given a deadline. So when a customer places a large order and he has a deadline, then you have to again work in a different way. When he doesn't give you a deadline, it's a different way, right? Because of the deadline, you may have to do major changes, right? And in the supply network is something like any raw material or even cooling water, which is a raw material. If that is going to be in short supply, conditions inside the factory, as I said, is some bearing has got into trouble and the machinery, the vibrations have gone up. You will have some time, but you eventually will have to shut down the plant and restart it. If that kind of condition is there, that is happening inside the factory. Okay, so this is just to give you a scenario, because subsequently also what you will be seeing, you if you know this kind of scenarios, you will understand it better. And this is driven by interconnection of hardware, software, people, and everything enabled by the internet. So industry 4.0 actually got a boost, or rather was born with the internet. When internet became more robust, this smart manufacturing and industry 4.0 actually had feet to start walking. Now you can say that we are kind of what you can walking briskly. We are still not running. It's going to take some time. Okay, now that is where I want to emphasize the aspect of maintenance. And Murthy sir is very closely work with these kind of situations. It is just smart manufacturing and making your machine smart. That is not really enough to make everything sustainable. As I said, or you may not know, but certain manufacturing units like a petrochemical unit, that can work continuously for years. I have seen it work for 2 and 3 years. In the Middle East, they run it for at least 2 or 3 years before they even take it down for shutdown. Just imagine the kind of planning that has to go into that. They of course have some balancing equipment where required, but still, to keep a manufacturing operation going on non-stop for 2 years also. I have run my manufacturing facility for 100 days non-stop, and for that time that was itself a big achievement. But now when I read and understand, that there were already other areas or other companies that are running manufacturing units for years together, right? So that kind of things require a big support from maintenance. And that's why I just want to spend this one slide to make you aware that in maintenance, so far, you start out with reactive maintenance. So in the very early days of manufacturing, when something breaks down, okay, you shut down your manufacturing operations and attend to the problem. So that used to be reactive. Because of the experience gained in those days, they said, yeah, some things we can see a pattern, that a bearing is this particular bearing fails every 6 months, and this particular what do you call equipment will have higher vibrations because the shaft is getting into trouble, it's losing its alignment. Sometimes simple fact that the foundations were not well made, loosen some bolt and you get vibration problems. So many things happen, but there was a pattern, especially in things like replacement of nuts and bolts, replacement of bearings. And these are all, what we call sacrificial components. That means you don't have to worry. A nut and bolt is not so costly as the equipment. Equipment is 100 times costlier than a nut or a bolt. But these things make a difference. And there you had this, then came the concept of preventive maintenance, where you from experience that, and this experience at that time was largely in the minds of the people, and some of it was noted down on logbooks. We used to have logbooks, so you note it down in the logbook, and then you one day sit down and go through the logbook of 1 or 2 years. You can easily see the pattern, and according to that you had a new way of maintaining, that's called preventive maintenance. Okay. And then when we had better quality measuring instruments, a vibration monitoring system itself, a vibration monitoring equipment itself were not easily available earlier. I don't know if any of you have seen a sound meter. Okay, even a sound meter was very costly when I used to take sound readings in something like let's say 1985 to 1990. Okay, getting a sound meter itself was difficult because they were not manufactured in India. The cost was very high, right? And because of that, very few companies had it. And even if you had it, if it got spoiled, you wait for another one to come. There was nothing like anybody could repair it. So it was all on and off. There was nothing continuous that could be done because of the given conditions prevailing at that time. So we had predictive maintenance, but we didn't have enough data. We had some data. It helped us to do preventive maintenance, and then predictive maintenance came with this kind of better monitoring devices. And then you had a lot of accurate data, and it became even clearer. So we just replace the bearing or bolts or whatever we know is going to give a problem once a certain period is done. Or it may be linked to, okay, if the vibration has reached this level, it should be replaced. Don't ask any question, just do it. That is the stage we are in today also. That is predictive maintenance. And again, for predictive maintenance, smart manufacturing is very, very useful. Or predictive maintenance is again lending a lot of support to smart manufacturing, because you can very accurately decide. So decision making is very easy, timeliness is much better, so you can do your maintenance and ensure that manufacturing is not affected very badly. Now they are thinking of moving from predictive to prescriptive maintenance. So efforts are on to move from predictive maintenance to prescriptive maintenance. What is prescriptive maintenance? It will ensure faster maintenance turnarounds. How does it happen? So let us say that you have a compressor, and in the compressor there are bearings, and the bearings are quite complicated. They have specific kind of bearing pads and associated equipment. That itself will be a list of 6 to 8 different items. Now if you find that the vibration of a compressor is going up, predictive maintenance, I already said, when levels are above this, you have to do maintenance. In prescriptive, the moment you see that readings have gone up, and now if it is smart manufacturing, it is real time. So you will even, first of all, you'll get one alert, you'll get an alarm saying that, okay, this has gone above threshold. So now you have to do this maintenance. But it doesn't only say that you have to do this maintenance by this time. It will tell you that for this maintenance you need this part. It's like bill of materials. Now you get a list of materials required to complete that maintenance, including the procedure for doing that maintenance, including information about whether those parts are available in your spares inventory, right? And maybe it will even alert the stores or manager. If it is not there, order it, because it will even show what is the lead time, or how many days it's going to take to get this part, and is it safe within that period. So predictive maintenance first tells you, okay, there is a problem, you have to change this bearing. Now predictive maintenance may also say you have a time of 24 hours or 48 hours, something like that. Prescriptive maintenance will base when all of this is coming from historical data. That is another important. And who allowed you to create historic data? The sensors. And sensors push this data into data warehouses, because the volume of data is huge. But because the volume of data is huge, the accuracy is very high, right? And that is where a combination of machine learning, mainly artificial intelligence, helps you not only to analyze, but along with that it will also give you other relevant useful information. So the moment you shut down, by the time all the material that is required to do the maintenance would have already reached the site. And they have also given all the drawings are now available ready in front of you, so you can see it on your tablet. The drawings are available, so which part, where, where was the vibration high, they can precise. It's like a doctor through X-rays, right, is able to identify clearly what is the size of the tumor, where exactly it is. So they will even mark on the body how much I have to cut, where I have to cut. Okay, that is the kind of support you get when you have prescriptive medicine. So keep this in mind, it will be useful to you. Okay, so I'll just go through these two slides and maybe I will switch to the video. So the key characteristics of smart manufacturing, it's there is a high degree of precision, high degree of inbuilt machine language based intelligence. I said for AI to work also you need that kind of algorithms to be created, and that is where machine language helps. So, and you have fast and accurate AI based decision making. So sometimes you don't even have to make the decision, the decision is already made for you. You just be ready to take your tools and start working. And there is real time interaction with all stakeholders. So in large companies, in the morning there is a meeting. So suppose there are 5 manufacturing units, all the heads will be there and the head of the company will be there, and they will have a dashboard on which they'll say, okay, how was the performance yesterday, what was the production, what was the limitations. If some production was not up to the mark, you have to explain what it is. Sometimes all those things are also available online. It will tell you that there was a cooling water shortage resulted in 10% reduction in production here, or somewhere it is that maintenance was planned but the part turned out to be not up to the mark or something. All of those information also is ready for the boss to just read, and then he has to only ask, okay, so what have you done about getting the replacement for this. That's how it is going today when you're looking at smart manufacturing. Okay, and this is real time because it might be just a few hours after the incident that everybody comes to know what has happened, what is to be done, who is responsible for it, and how fast it will be done. Now these are the key issues in smart manufacturing. That's why it is smart. Hmm? And the benefits are, of course, you have optimal resource utilization. It gives you a competitive edge, especially if somebody doesn't have smart manufacturing, then you are really having a big competitive edge. And if your product is consistent in quality, timely in delivery and all that, customer satisfaction is a given, right? And you can even go for customized products in certain kind of situations. Okay, and this leaves intelligent people free to think of innovation, creativity, and bring in some more good ideas, right? So okay, let me just finish off with this. Okay, I'll come back to this. So let me see if I can get the video running to our satisfaction. Okay, so can you see this screen now? Can you see the video screen, sir? Any of you, can you see the video screen?
No, it is a black screen.
Blank screen. Okay, let me just see. Yeah, I may have to stop sharing and start again with a new screen. Okay, is it now coming up?
Yes, yes, yes.
So you can see video. So I'm going to start running it. Let's hope all of you have a fairly good experience.
Said that soon all the company's plants will be just like that. Should people be
So
afraid of
let
losing
me
their
see. I'll just start right from the beginning. Okay, it's the speech is a little fast, so you'll have to be a little alert. But I will interrupt in between.
Nissan showed production without people and
So this is Nissan showed that production can be carried out without people. That's what he says.
said that soon all the company's plants will be just like that. Should people be afraid of losing their jobs? And what else can we expect from Industry 4.0 in the near future? Well, in today's
So you see, this is again making use of virtual reality or augmented reality. Okay, this is one direct case of augmented. This is what you see in the center is not the physical machine. It is a virtual machine where you can actually see the parts as they are in the physical machine. Okay, this may be inside. Yeah, because it is Nissan, it is like probably something linked with the. No, this inside looks like a pump and something because you have an impeller at the bottom. Okay, or it could be a turbine. But anyway, just watch.
episode, Nissan showed production without people. All the work is done by robots. Basically, we have seen this before. For example, Elon Musk tried to remove people from production at his factory in Fremont, but then was forced to admit that people are undervalued. Even earlier, in the mid 80s, Steve Jobs decided to produce computers in a robot factory and even started it up. But PC component sizes were changing at an incredible rate, and
Here also it's very important to understand the importance of standardization. Okay, it is a fact. If you read articles, you'll see Tesla really suffered a big setback. They spent a lot of money to set up a almost fully automated plant, but it could not because there were some problems in their planning and design. Okay, so I'm just giving you the background, right?
Reconfiguring the factory was slow and expensive. Eventually, the factory closed. So, how is Nissan's manufacturing any different from past experiences? The Nissan Intelligent Factory production line is not just as robotic as possible. The main feature of the factory is that humans no longer make any adjustments to production. The robots themselves do that, equipped with artificial intelligence. They independently analyze the data they receive and can assemble all three types of Nissan vehicle models.
So make a note of that. It is not just making one car in the same way. They are talking of three different models with whatever differences are there. That itself is managed through artificial intelligence built into the manufacturing facility.
Without any readjustment, with internal combustion engines, electric or hybrid, as each vehicle moves down the assembly line, it's equipped with the right powertrain. Also, the process is streamlined. For example, a new type of paint allows the car bodies and bumpers to be painted and baked at the exact same time, reducing energy consumption by 25%. The car
You may not be aware, but in car manufacture, and at least you know that your car, the front fender, no, that is mostly plastic, whereas your body is metal, right? Now, they have to put in a lot of effort to make sure that you have the same paint on both. Both have to be painted separately, at least until this kind of a facility comes. Here, they would have changed the manufacturing. I mean, the quality of the paint and some changes in the material of construction of that plastic as well as the metal body. But you see the kind of advantage they get. So in one shot, you can paint both the fender and the body, and that reduces a lot of time. And maybe to some extent, it might be costing a little more, but it reduces time so much that it pays off, right? Just watch.
carbon footprint of the new plant has been minimized. The company assures that similar innovations will gradually be introduced at other plants around the world. However, there are still few people at the factory, and they analyze the data collected by the robots and also engage in the maintenance of the equipment.
So you can see, the control room operator or the supervisor, they can see exactly what is happening in any part of the manufacturing unit. This one might be something to do with a little maintenance or adjustments, but by and large, there is nobody, touching the manufacturing process. Okay, but you can see all of that in a remote place. Now, that is where I meant that if it is just a local network, you can see it in a room, inside the complex, but when you have the internet, you can see it from anywhere in the world. That's the main difference. And because of internet, all this data, if you don't have space inside your complex to store it, or if you don't have a high-end sophisticated software which you use only once or twice in the whole year, then also it is useful, because when it is in the cloud, cloud gives you on rent basis business intelligence software, so you don't even have to buy it. Now these are the kind of advantages that cloud brings, besides the fact that they can easily store lot of data which you cannot think of, right? So let's see ahead what else you get to learn.
Previously, the biggest problem of robotic factories was considered a lack of flexibility, and only humans could boast a quick retraining, requalification, and the ability to adapt to these changing conditions. But what about now? Well, Industry 4.0, or the Fourth Industrial Revolution, has already happened, and we haven't even noticed. Well, it almost has. And here are the main reasons and trends that have changed the manufacturing and labor market. The first reason is the development of artificial intelligence to the point where projects with it become commercially successful. Advanced AI enables preventative maintenance, cognitive computing, swarm intelligence, context aware computing, generative design, and more. For example, startup Mechanica AI offers industry grade AI capable of integrating with legacy assets and using imperfect manufacturing data to make autonomous decisions. By integrating industry knowledge into artificial intelligence, the company is developing a universal AI model that is accessible and useful to any enterprise. The second catalyst for Industry 4.0 is digital twins and
So here you get the first glimpse of digital twin, right? You can see that not only is there a physical car, an exact same model is also moving along with that car in the digital form. So you can get an idea if something is going wrong, what is happening inside the car. So I'm just continuing. I'll take question answers after the video is over, and you can even see it again. I have put this link in the I think the first one or two slides. It is there. You should go back and see this two or three times if you really want to understand the different aspects of smart manufacturing. Even the names of different technologies that are acting as enablers, that's also mentioned in this video. Almost all the items that were listed yesterday are covered in this. Okay, just watch.
Performance verification modeling. Now, you don't
See, you can see the data screens also. You're not just seeing visual of the virtual car. You're seeing the related data also on the screens. Okay, so that is what is the more important part. Okay, and this is what is called visualization. So you will come across this very often. That now the level of visualization, because if when we studied in engineering, we didn't even get to see simulation. On a simulation itself was a highly complex thing, and very few people had access to it. But today it's come home. You can see it in your home. You can see it for free, and you can use this either to definitely to enhance your knowledge. But I think some of you will find it inspiring. So watch this.
have to do anything in reality to make sure that complex robot software is correct, or even an entire factory is built correctly. It's enough to create a digital twin and use it to test.
So the digital twin, you can create anything from one component or one full equipment. Component means, let's say you're looking at the shaft with the bearings mounted, that is a component. When you look at a pump and motor assembly, that's an equipment. Okay, and here they are talking about you can have this entire factory also in virtual form. That helps you to understand layout, and you can do this virtualization before the manufacturing unit is built. So it helps you to plan accurately for making your design of the building itself, its wiring, its sizes, elevations, how much floor to space, floor to roof distance should be maintained, floor to ceiling. All those things you can get it by just first virtualizing this virtual factory, and all this is possible, right?
All the technologies and processes in a simulated
So here you see this is the digital twin for a motor.
environment. Additionally, the production can be quickly adapted to any changes, creating a digital twin that's able to independently monitor variables and optimize them real time. The third trend of Industry 4.0 is additive manufacturing.
Additive manufacturing is just another word for 3D printing, especially as used for industrial components. But you'll see the brilliant benefit for certain type of situations that additive printing brings. So you'll see it here.
Originating as a rapid prototyping technology, 3D printing is revolutionizing manufacturing, making it easier to produce complex parts. Advances in material science, stereolithography, and 3D metal printing are pushing the boundaries of offline production. The technology has already
Just watch this portion of the video. This is the high end benefit in 3D printing. Just watch it.
reached the micrometer scale of printing. For example, the Swiss startup Exato is developing the series system, which allows printing complex metal objects ranging in size from 1 to 1,000 micrometers. But the more technology advanced and autonomous in the production, the more individual and delicate its settings are, the more acute the issue of privacy and cybersecurity is. But there's new technologies being developed right now to ensure the safety. Self-adaptive security, zero trust security, and end-to-end communication security, DevSecOps, and blockchain are just some of the new developments in this direction.
So you heard the word blockchain, right? So even in smart manufacturing, to maintain the integrity of the data, one of the strongest reasons why blockchain is so popular today, and we might be doing a session on blockchain and cryptocurrency at a subsequent day, is because once data goes inside a blockchain, nobody can change it. Okay, that is one feature which is actually driving the developments in blockchain and related applications. Cryptocurrency happened to be the first. Don't be surprised, after some time that will be like I mean, something very small compared to what blockchain will be doing in the days ahead. Just watch.
Another example is the robot immune system being developed by the Spanish startup Alias Robotics. This platform protects robots and their components from malware and offers a secure data logger to investigate cyber attacks or robot failures. Another startup, Autolus, is developing FACT, a system that secures software updates for all factory devices. It collects unique file fingerprints from hardware vendors and compares them with those obtained by manufacturers. FACT gives a credibility assessment during the installation of the update on.
If you recall, there was a controversy about Huawei, and I think Huawei was banned in the US, and then there was a case registered in Canada, and the chief, I think the CEO, was jailed for some time and for many months,
Yeah,
right?
3 years. She was jailed for 3 years.
Yes, and that is because now this is the technology or the use of software. It will have a fingerprint when equipment is designed. That means on the drawing board, and afterwards when it is physically manufactured and supplied to a customer, again the fingerprint will be compared. What it does is, if anybody has changed anything in that design, all right, then also it will give a fingerprint difference, and because of that you will have suspicions and you will take corrective action. So you see the level to which it is going today. That was the purpose. Watch it, there's still a little
Different manufacturers' equipment.
more to see.
But technology isn't just pumping up robots, it's also pumping up humans. Wearable exoskeletons enhance workers' physical strength and endurance.
Watch this carefully. This is part of machine learning. So, how will a robot tighten a bolt? Actually, the sensors are right now on the body of these two mechanics, and they are sending feedback about how their hands work, how much strength the muscles are applying, what is the posture, which one is most ergonomic, or which one is most efficient, right? All these aspects are being monitored from these two people. So you can see that contraptions that they are wearing, that is to aid the machine. Okay, and that is where machine language comes into picture. This is almost like self learning. So this data is directly, or it can be directly fed into the robo, and robo will start doing the tightening of the bolts exactly as these people are doing. And then wherever little deviations are there, that can be easily correct. Now you don't have to write the code to do all of it from scratch. I hope you understand this. If this kind of measurement was not there, you will have to program, right? In the program, go left, go up, go this, go that. Now you don't have to do that. The way in which these people are working, everything is measured, and that becomes the base. That data is directly fed into the machine. So a lot of your programming time and effort is brought down. Keep watching.
Of course, even with them, people won't be able to work 24/7 like a robot, but we are more versatile and flexible. So, maybe we still have a chance to compete with robots for jobs. The second technology coming our way to help us compete for robot jobs in factories is.
So, sorry, what did I do? Let me see.
Nissan showed production without people and said that soon all the company's plants will be
Sorry,
just
sorry,
like
I'll
that.
just bring it
They
back.
independently analyzed it's also pumping up humans.
Okay.
Wearable exoskeletons enhance workers' physical strength and endurance. Of course, even with them, people won't be able to work 24/7 like a robot, but we are more versatile and flexible. So, maybe we still have a chance to compete with robots for jobs. The second technology coming our way to help us compete for robot jobs in factories.
So if you recall, yesterday he mentioned virtual reality, augmented reality, and mixed reality. But you are going now one level higher. It can be extended reality, which actually combines all three into one, right? And that is the device this person is wearing. Is the video playing all right?
Yeah.
Okay, fine. Thank you.
Is the future XR technology. They include mixed reality, augmented reality, and virtual reality. They are mostly used for research and development, but they can also be part of an intuitive machine control interface or a full scale manufacturing and post production process. Robots can also play on the side of humans, especially if they are cobots, machines designed specifically.
I'll just take it back a little. You saw the human body, did you?
Yes.
right? This is actually something before surgery. This is what a
Nissan showed
doctor
production
does.
without people and said that soon all the company's plants will be just past plants around the
I'm
world.
sorry, I'm having a little problem with.
Robots can also play on the side of humans, especially if they are cobots, machines designed specifically to work alongside humans and not replace them. Cobots make human tasks more efficient. They are easy to set up, they're flexible, and inexpensive when compared to other robots. Yet, they can be accurate to 0.1 millimeters and carry small loads on the order of 5 kilograms over short distances up to 1 to 1.5 meters. But despite the high expectations that have been placed on robots over the last couple of years, they still haven't flooded the planet yet. In general, robotics is evolving. The industrial robots in manufacturing, logistic robots in warehouses, collaborative automated systems, humanoid robots, and robot grippers that can work with any object. All of this brings together the Internet of Everything. This is also the trend of Industry 4.0, which includes real-time machine-to-machine, human-to-machine.
So this is a virtual factory, okay, and that's what you can. It's like a digital twin of the manufacturing unit.
And human-to-human communication. This is the industrial Internet of Things, Internet of Skills, Internet of Services, Internet of Systems, and Internet of Things on the shop, and Internet of Things on the shop floor. The Internet of Everything combines real-time data, machine intelligence, and human skills, resulting in faster, more efficient, and cost-effective manufacturing processes. And we want to believe that this will be the manufacturing of the future, where human ingenuity, experience, and creative thinking will complement the physical strength and precision of intelligent robots that are responsible to the commands of their living masters. What do you think the future will look like? Let us know in the comments. And while you're here, subscribe to the Pro Robot channel and don't miss any new episodes from the world of high tech.
So I hope you enjoyed seeing that.
Yeah, very interesting. Highly complex technologies.
Yeah, actually, I missed pausing that one place where you could see in that 3D printing section. All of you can go back to that video when you get the time. In that 3D printing section, there are certain types of what do you call a distributor, like what you need in the carburetor of your car. In a aeroplane, you may need this fuel mixture to be mixed in a certain way to get the best energy output.
Yeah.
Those designs are not possible even through the conventional CNC machines and things like. You can only do it through 3D printing. Okay,
Oh,
so you only have to now look at the material, and according to that you use it in the 3D printing, and that will help you to make those kind of designs which otherwise is not possible. So I'm going back to the presentation. You have seen all of these benefits, but
Bhavsar
yeah,
sir, just to update,
yes,
we had a session on 3D printing by Dinesh Kokte,
correct,
beginning, 8th of
yes, yes,
November.
yes,
So,
yes,
so there he briefly explained it was only one session.
yeah,
He could
yeah.
not go
No,
into detail. He gave an overview.
what I am trying to emphasize is, see, 3D printing of a part which is conventional is a simple thing. Okay, if you
Correct.
want to make plastic gears, then you just use a 3D printer. Nowadays, you don't go and look for a mold shop and then tell that, okay, I want this kind of gears, thousand in
Correct.
number. You can do it through 3D printing. But
Right.
what is the real contribution in 3D printing is intricate designs, and this is tomorrow. Don't be surprised, your kidney also will be 3D printed. They are
Oh,
saying they can 3D print organs, and there you have to feed cells, living cells from the human body. Now,
oh, oh.
because just recall, when a child is conceived, right? You're all old enough to understand that it all starts just from one cell, but two cells combining, it again becomes one cell, and then it is what do you call self division, is it not? Mitosis, meiosis, if you recall those words, it is nothing but the male and female cells fuse. It makes one cell, the genes combine, and then they just keep on dividing exponentially. Okay,
Correct.
how does it become a hand? How does it become a heart? How do you get a kidney in that child's body? That is actually the beauty of nature. And something is happening no inside. It is nothing but these cells are slowly accumulating, they form clusters. And again, this is happening because the genes are designed like that, and
Right.
each cluster of cells will become one organ, and
Right.
like that other parts of the body. What an amazing technology that is. We still haven't mastered that.
Correct.
And if you want to look at God, you should look at God from this perspective, that we think we are very smart, we have done so much. Just imagine how before the evolution of man, or at the time of evolution of human beings, who must have planned this? Let it be nature, you can call that God. But can you appreciate the level of detail, the scientific understanding that should be there? Or is it something that nature has done by itself? Even if nature has done by itself, that's a very great thing. We are still very small compared to that nature. That's what you should call God. You understand what I'm trying to say? Think
Yes.
like that, we'll become better human beings,
Yes.
right? So these risks are already shown, but these are very crucial risks, because safety of personnel. I mean, if a robot goes rogue, anybody walking around could get slapped. Change management. That means, especially see, it's very easy when you're having something coming up from ground up. So if you're starting from scratch, you can purchase equipment ready to be wired. But if you have a legacy manufacturing system and you don't want to replace all the machinery, that's a tough job to do. And same happens with the people who are working till smart manufacturing came into the picture. What do? You ask them to leave? I don't think any company wants to do that, right? So you have to train them, and that change management is a very difficult thing. You will learn this when you start working and have been there for, been in the job role for at least, about 5 to 10 years, and you'll understand what is change management and how difficult it is. Okay, to change the minds of people. You can change the working of a machine in hours, but it may take you years, or maybe even then you will not succeed when it comes to changing the mindset of people. But that is also a challenge that you have to handle. Social impact, yes. One of the bigger worries now is, like what is happening today. We don't go for a walk. We might be spending so much time on the screen. uh, I mean, I think Tim Cook or somebody said it. If I spend more time seeing the screen than what I spend with people, something is wrong with me. That's what Tim Cook says. Apple's Tim Cook. If I'm not wrong, it is Tim Cook. He says we are doing a big blunder if we think that the screen is going to give us everything. And don't make that mistake of spending so much time on your screen that you forget how to interact with people.
In
Okay,
fact, sir,
so that's about adverse social impact. Yes, sir.
Anshul has raised the hand.
Yes,
Actually.
sir. Anything you want to add, sir?
Anshul.
Yes, sir. So, in change management, so basically, sir, whenever a new company wants to implement a ERP system, so it is similar to that. We have to train all the
Okay, I
employees and
think,
everything.
yeah, yeah. Yes, yes. I think something is happening in the sound side, but let me see. I'm not able to hear everything clearly. I'll just finish up with this presentation, and maybe then we'll see face to face and I'll answer questions. Okay.
Yes,
I'm
sir.
going
Yes,
through
sir.
these slides pretty fast because you will get them, and if you read them, you will understand. I wanted to show you something because I think a picture is worth more than pages, right? And a video is even more impactful than pictures, right? Because this is the reality. This is actually happening in Japan. So of course, the other two areas is business continuity also can become dependent on connectivity. Okay, and sometimes you will have external consultants and external experts, playing a bigger role inside your manufacturing operation. So you have to just keep that in mind. Security, of course, is the highest concern, and that is one place where blockchain is going to play a very big role, right? But today, because there is a lot of data flow, the scope, the risk of something going wrong with the data, even without any hacker coming into the picture also, there could be a hardware fault or something, and if that data gets into trouble, your instructions coming back to the sensors also can get into trouble. So that is the simplest thing. But the worst part is, I hope you can go back and search the internet. The nuclear plant in Iran, whether it was Israel or US, I can't say, but they could shut down all the centrifuges in the nuclear plant of Iran. Who did it is still a mystery, but it can be done. That is what is security. I mean, that is the level to which you have to think if you want to keep your manufacturing operations secure. Okay. This is nothing but all the enabling technology, so nothing more to say there. And this is the concept of digital twins. Since you have now seen the virtual representation, you will understand that digital twin is a virtual representation of as designed, as built, and as maintained physical product. So you can see it at the design stage, you can see it as at a built stage, and as it is being maintained. So when it is in operation also, a lot of data that is getting generated and sent to you by sensor helps you to understand, is it conforming to design. Okay. First, when it is built, you can match it with design. When it is operating, you can match it with design. And when things deviate, you know what you can plan on what to do. And this is augmented by real time process data and analytics based on accurate configuration of the physical product or the production system or the equipment. Digital twins are poised to transform manufacturing processes and offer new ways to reduce costs, monitor assets, optimize maintenance, reduce downtime, and enable the creation of other connected products. So, a simple picture is, but you have already seen it on the videos. This is what it will look like. You could have a photograph like this up before the supervisor, and he can see a digital twin of the motor and then do comparison of the readings that he is seeing on his screens. So this is digital twin used in production for a running machine. This is the case of a digital twin being used at the design stage. So even before it is built, you can see how it is going to look like, and what is even the dimensions, even the material, right? Everything you can make out using this virtual digital twin. This is all possible through software and augmented reality. Fine. And I think there are just 2 3 slides. So these are the benefits of digital twin. You can do predictive maintenance, you can do real time remote monitoring, because if it is connected through internet, that data is in fact, now what will happen is this data will like I think I told you in IoT that in a connected car system, the manufacturer of the car is automatically getting all the data even while the car is running. So something like that will happen for manufacturing equipment also. You will be sending data to the original designer of those equipment, and they know better than the team operating it in many other aspects. So you have better collaboration, right? And all of this leads to better financial decision making, because you can see your profits coming in, right? Because of reduced time, right? Because of faster maintenance, so many factors. It's all leading to better, more profits. And here again, this is what we have already seen, that the main thing you have to consider when you go for smart manufacturing as well as when you adopt digital twins is ensure that your data is secure. Data part is very, very crucial. And the last part is, yeah, the additional 2 points, even manage your data quality. As I said, you should be getting data from all the places possible and at a speed that is required. And last, the very important part, your team should understand and know how to maintain that. So this is where my presentation actually gets over. I will leave it, I will close this so that we can have a face to face discussion. Okay.